Hi guys, in this video we'll discuss memory and causality property of a system. Okay, so a system is said to be memoryless. Whenever we say memoryless, it's also called a static system. Okay, so if the system's output y of t at any value of time t depends upon the input x of t at same value of time t only, then the system is called as memoryless. For example, if y of t at t is equal to 10 is equal to x of t at t is equal to 10, then the system is called as memoryless. I repeat again, if the output of the system for every value of time depends upon the input x of t at the same value of time only, then the system is called as static system or memoryless. And how do we define for memory? So system has memory, we also call it as it's a dynamic system. A system is said to have memory if its output y of t depends on past or future value of the input x of t. Let me make it simpler. If the present output depends upon present input value, then the system is called as memoryless. If the present output or if the output of the system depends on past or future value of the input, then the system is called as it has memory or it is dynamic system. Right? So this is about defining memory and memoryless of a system. Next, if we come to the causality, a system is said to be causal if its present output y of t depends on the past and or present input x of t. So I repeat again, if the present output depends on past and or present input x of t, then the system is called as causal. And the system is said to be non-causal if the present output depends upon if output any instant of time depends on future value of the input, then the system is called as non-causal. Remember like this, if the system depends upon future input value, if the system output depends upon the future input value, then the system is non-causal. Otherwise, system is causal. Right? So before I take up the problem, let me just tell you what do you mean by past input, present input, past output values. Okay, consider an input signal x of t, and I'm trying to convince you with continuous time. This holds good for discrete time also. Okay, this is at time t equal to 0. This is my x of t input signal with some random arbitrary input. Okay, and output to that system, say this is at t equal to 0, output from the system is y of t, and we get some random output. Okay, now the present output of a system can be anywhere for t varying from minus infinity to infinity. With respect to that present output, we will have to define past input value and future input value. Okay, so for example, if I consider this point as my present output, and this is present input. Why present input? Because with respect to the input signal, and this is present output because this is with respect to the output signal. Now with respect to present output, left hand side to this dashed line is actually past input values, and right hand side to the dashed line, everything is actually future input value. Okay, so if I consider this as my present output. Okay, similarly, if I take up somewhere here as my present output value, if this is my present output value, and this is present input, then left hand side to this dash line is actually past input value, and right hand side to this everywhere is actually future input value. So this is how we define present input value or present output value, past input value, and future input value. In the next video, we'll take up some examples to convince you how we check for systems memory and causality.